In this video, I'm going to go over how to calculate the z-statistic and how to interpret your obtained z-statistic when we're testing hypotheses. So to do this, we use this formula here, which is y bar minus mu bar divided by sigma y over the standard deviation of n. Written out in words, that is the sample mean minus the population mean divided by the population standard deviation divided by the square root of the total. And that's the total sample size, okay? Once we obtain this z-statistic, we're going to compare it to our critical z-statistic to interpret the results. So for this problem, we're going to use this data here. We sampled 100 Toyotas and we found that their average gas mileage was 32 miles per gallon, okay? So this is the average gas mileage of these 100 Toyotas that we sampled. We also know that the average miles per gallon of all cars, the population mean, mu bar, is 29 miles per gallon. Okay. And the population's standard deviation is 5 miles per gallon. Okay? So on average, scores within the population are within 5 miles per gallon of 29. So, are we statistically sure that this sample's mean of 32 is actually higher than the population's mean of 29? Right? That's the question that we're asking. So our research hypothesis is that the gas mileage of Toyotas is greater than the gas mileage of all cars. Okay? Then our null hypothesis is the opposite of that the mileage of Toyotas is less than or equal to the mileage of all cars. So you're looking at these two numbers, 32 miles per gallon and 29 miles per gallon, and you're saying, well, obviously 32 is higher than 29. However, we need to make sure that this greater number isn't just due to sampling error. What if we chose 100 Toyotas and those just happen to be the most gas efficient Toyotas? We don't know. So we have to do a statistical test to make sure that we are confident that this number that we obtained, 32 miles per gallon, isn't due to sampling error. That's why we do this statistical test, okay? Is to make sure that this value is actually statistically greater than this value. So we're going to calculate our z-statistic. So z-statistic, using our nice formula, sample mean, that's 32, minus population mean, which is 29, over this population standard deviation, which is 5, divided by the square root of the sample size. We have 100 cars in our sample, so our sample size is 100. Okay, so working this out, we have 3 in the numerator, and then on the denominator, we're going to have 5 divided by the square root of 100 is 10. So that's going to give us 3 over 0.5, giving us a z-statistic of 6. So this number, 6, is our obtained z-statistic. Now, what we do with the obtained z-statistic is we compare it to a critical z. So we have to determine if we have a one-tailed test or a two-tailed test. In our example, we used a greater than sign in our research hypothesis, so we have a one-tailed test. One-tailed tests have a greater than sign or a less than sign in their research hypothesis. Okay? Two-tailed tests have a not equal to sign in their research hypothesis. So this would be An example of a two-tailed test would be the gas mileage of Toyotas is not equal or is different than the average gas mileage of all cars. However, in this case, we're pretty sure that our Toyotas have a higher gas mileage than the rest of the cars, right? So we have a greater than sign in our research hypothesis, making it a one-tailed test. Now what we're going to do with our z-statistic is we're going to compare it to each of these critical z-scores that correspond to different levels of alpha. And what these different levels of alpha tell us is our confidence that our obtained z-statistic is significantly greater than our population mean, okay? So, we're going to take our obtained z-statistic of 6 and we're going to see if it's greater than each of these numbers. So is 6 greater than 1.645? Yes, so we can pass this test. We've passed this test. Is our 6 greater than 2.325? Yes, 6 is greater than 2.325. And the last one is 6 greater than 3.08? Again, yes. So because our obtained z-statistic is greater than all of these values, or any of these values, we're going to say that we reject the null hypothesis. So the first thing we're going to do is decide whether or not to reject the null hypothesis. If your obtained z-statistic is greater than any of these values, these critical z-scores, then you always reject the null hypothesis. If your obtained z-statistic is less than the lowest of these critical z-values, which is 1.645, then you would fail to reject the null hypothesis. However, in this case, our obtained z is greater than all of these, right? So we're going to reject the null hypothesis, okay? We are going to conclude that we are, and here's where we look at our alpha. Okay, so we look at the highest alpha that we were able to pass with our obtained z-statistic. Okay, in this case, we've passed all of them. Okay, so that's an alpha of 0.001. An alpha of 0.001 corresponds to a 99% confidence level. So we're going to conclude that we are 99.9% confident that Toyotas, that's our mileage of Toyotas, have greater gas mileage than all cars on average. Okay, so this is the full interpretation of our obtained z-statistic of 6. The first thing we do is decide whether we reject the null or fail to reject the null. Then we form a conclusion based on the alpha level that we were able to surpass. So in this case, we were able to surpass all of the alphas. However, if we worked through this problem and we obtained a z-statistic of 2, then we would go up here, we compare our obtained z-statistic to these values up here. So is 2 greater than 1.645? Yes. Is it greater than 2.325? No. So we'd have to stop here at an alpha of 0.05. But since our obtained z-statistic is higher than at least one alpha, we still reject the null. Okay? However, instead of concluding that we are 99.9% confident that Toyotas have greater gas mileage than all cars on average, we would only be 95% confident. Okay? 95% confident. Because an alpha of 0.05 corresponds to a 95% confidence level, right? And a 0.01 alpha is a 99% confidence level. So that is how we calculate z-statistics and how we interpret z-statistics. I hope this helps.